Hello everyone, welcome to Infinity Learn by Sri Chaitanya. Let's start weekend test 4 physics part AIIMS question paper. So question number 1 is for a liquid in a vessel, the force of cohesion is twice the force of adhesion. Then the wrong statement is. So if force of cohesion is more as compared to the force of adhesion, the meniscus is always convex and the angle of contact is obtuse angle, and in this case our liquid will not wet the solid surface, right, like in mercury and glass tube, and there will be capillary descent. So correct statement is option 2. The liquid will wet the solid is the wrong statement. So correct answer is option 2. Question number 2. The figure shows the vertical section of a frictionless surface. Block of mass 2 kg is released from rest from position A. Its kinetic energy at C is. What will be the kinetic energy of the particle at C? So when you release one particle from A, it will follow a path something like this and it will come to C, right? Now this is frictionless surface. That means total mechanical energy of the surface is conserved. If there is some loss in potential energy, that loss will be converted into gain in kinetic energy. Initial kinetic energy is 0. Final kinetic energy at C is, let's say, K. So gain in kinetic energy is K minus 0, and that is equals to loss in potential energy. So it will be mg 14 minus mg 7. M is given as 2, G is 10, and 14 minus 7 is 7. So it is 140 joule. Correct answer is option A. Question number 3. Work done by a conservative force on a system is equal to. So work done by conservative force is minus of change in potential energy of the system. So correct answer is option 2. Question number 4. A cylinder containing water stands on a table of height capital H. Okay, so we have a cylinder and it is placed on a table and its height is capital H from the surface. A small hole is punched on the side of the cylinder at its base. Over here, small hole is punched. The stream of water strikes the ground at a horizontal distance r from the table. So stream of water will strike the ground at a distance r from the table. So the range of this water stream is given as r. Then the depth of the water in the cylinder is, let's say depth of the water in the cylinder is h. Then according to Torricelli's theorem, the speed of the water coming out of this hole will be under root 2gh, right? So range is under root 2gh, velocity into time, so time is under root 2h by g. Okay, so let's square on both the sides. If you square on both the sides, so r square will be 2gh into 2h by g. This g will cancel this g, so we have small h is equals to r square divided by 4 times capital H, and this will be the height of the water in the cylinder, which is option 4. Question number 5. Height from the surface of earth at which value of g becomes 1 by 4 to that near its surface is. Radius of the earth is 6400 kilometer. So variation of g due to height is given as g dash is equals to g in upon 1 plus h by r whole square. G dash is g by 4, right? So if you compare these two expressions, you'll get 1 plus h by r whole square is equal to 4. Take the square root on both the sides, so you'll get 1 plus h by r is equals to 2. So basically h by r is 2 minus 1, which is 1, and h is equals to r. So height will be equal to radius of the earth, which is equals to 6400 kilometer, which is option 1. Question number 6. A 4 kilogram steel ball moving with velocity 4 meter per second. So 4 kilogram steel ball is moving with velocity 4 meter per second. Collide head on with a stationary steel ball of mass 2 kilogram. This ball is at rest. If coefficient of restitution is 0.5, then speed of 4 kilogram ball after the impact is. So let's say after the impact 4 kilogram is moving with v1 velocity. So v1 can be written as m1 minus em2 divided by m1 plus m2 into u1 plus 2, sorry, it's 1 plus e into m2 u2 divided by m1 plus m2, right? So m1 is 4 minus e is 0.5, m2 is 2, divided by m1 plus m2, 4 plus 2 6 into u1, which is equals to 4 meter per second, plus the second term will be 0 because u2 is 0, so this will be 0. So we have 4 minus 1 3, 3 by 6 into 4, which is equal to 2 meter per second. So after the impact, the value of velocity of 4 kilogram will be 2 meter per second. Question number 7. Water is flowing through a horizontal pipe of varying cross-sectional area. Cross-sectional area of the pipe at A and B are 20 centimeters square and 5 centimeters square respectively. The pressure difference between point A and B is. So let's assume that pressure at this point is PA and pressure at this point is PB. Velocity at point A is given as 2 meter per second. Velocity at point B is not given. So we can apply equation of continuity to find the velocity at point A. So it is PA into area of cross section at A is equals to, sorry, VA into area of cross section at A into VB into area of cross section at B. V1 V2 is A1 V1 is equals to A2 V2. VA is 2, AA is 20 is equals to VB is unknown, AB is 5. So VB will be 8 meter per second. At this location, the velocity of water is 8 meter per second. Now we can apply Bernoulli's equation. Now point A and B are at the same height, bachcho. Point A and B are at the same height, right? So you can apply the conservation of total energy per unit volume at point A and point B. So for point A it is PA plus half rho VA square plus rho G HA is equals to, for point B it is PB plus half rho VB square plus rho G HB. Right. Now, HA and HE both are equal because we are talking about the horizontal pipe, right? So this term will equate this term. So this term will cancel this term. So basically we have PA plus half rho of water is 1000 into VA square, which is 2 square, is equals to PB plus half rho, which is again 1000 into VB square, which is 8 square, right? So PA minus PB is equals to this is 500 into 64 minus this is 500 into 4, which is equals to 500 into 60, and if you solve this one further you'll get your answer as 3 into 10 power 4 Newton per meter square, which is option 1. I hope this is clear. Question number 8. There will be no phenomena of capillarity in outer space where gravity is 0 and atmospheric pressure is 0. Okay. If angle of contact is 0, if the liquid at its freezing point, and if the liquid at its boiling point. So correct answer is option 4. If the liquid at its boiling point. At a boiling point there will be no surface tension, right? So there will be no capillarity. So correct answer is option 4. Question number 9. Kinetic energy of a body is K. So let's assume that its mass is m, velocity is u. So half mu square is given as K. If 1/4 of its mass is removed and velocity is doubled, its new kinetic energy is. So m dash, that is the new mass, is m minus m by 4, which is 3m by 4. And its velocity v dash is 2u. So it is just 2u. Right, new kinetic energy K dash is half into 3m by 4 into 2u whole square. So it is half 3m by 4 into 4u square. 4 se 4 cancel. So we have half mu square times 3. Right. So K dash is basically 3 times K, which is option 2. Question number 10. A force vector 2i cap plus 3j cap plus 2k cap Newton acts on a body for 4 seconds and produces a displacement vector 3 I cap plus 4j cap plus 5k cap meter. Calculate the power. So power is rate of doing work. Work is force dot displacement vector. So work will be F vector dot R vector, which is equals to 2 into 3 plus 3 into 4 plus 2 into 5. So it is 6 plus 12 plus 10, that is equal to 28 joules. So power is work upon time. So it is 28 divided by time is 4, that is equals to 7 watt. So correct answer is option 3. Question number 11. A lighter body collides head-on and elastically with heavier body at rest, then after collision. So this is the special case of elastic collision. If lighter body collides with the heavier body and the nature of the collision is elastic and head-on, so after collision, lighter body will change its direction and move with the same speed, and heavier body will not move. It will remain approximately at zero speed. Right? So correct answer is option 2. The velocity of lighter body is reversed and the final velocity of heavier body approximately remains 0. Question number 12. A uniform meter scale of mass 2 kg is suspended from one end. So this is your meter scale and it is suspended from one end, something like this. If it is displaced through an angle of 60 degree from the vertical, find its increase in potential energy. So we are displacing this meter scale at an angle of 60 degree with the vertical. So its center of mass was initially here, now it is here. So there is some increase in the height of vertical height of the center of mass. Let's say this height is h. Okay. Now this is L by 2. Right, so this length will be L by 2 cos 60 degree. So L by 2 cos 60 degree plus height is equals to L by 2 for this one, right? So height will be L by 2 minus L by 2 cos 60 degree, which is equals to L by 4. So height increase is L by 4, right? So change in increase in potential energy will be mgh, which is L by 4. M is 2, G is 9.8 and L by 4, that is 1 by 4, and that is equals to 4.9 joules, which is option 1. Next is question number 13. Two identical balls A and B having velocities 0.5 meter per second and minus 0.3 meter per second respectively collide elastically in one dimension. So we have two identical balls A and B, and initially these balls are moving with 0.5 meter per second and minus 0.3 meter per second. And the nature of the collision is elastic and head-on. So velocity of B and A after the collision will be. So after the collision, identical balls changes their velocities, exchange their velocities, right? So after collision, A will gain the velocity of B, which is minus 0.3 meter per second, and B will get the velocity of A, which is 0.5 meter per second. So velocity of B and A will be 0.5 and minus 0.3 meter per second respectively. Okay, next is collision doesn't require physical contact. Yes, this one is true. Collision doesn't require physical contact. Why? Because collision is the event where, after some forces, the value of momentum of the particle changes, right? So like in the case of electron and electron, there's repulsive force, and because of the repulsive forces the momentum of the particle is changing, right? Collision between subatomic particles is elastic. Yes, between subatomic particle, if the subatomic particle comes closer to each other, what will happen? Because of the repulsion, after a certain distance they will move away from each other. So without contact, the momentum of the particle is changing, right? So yes, if there's no contact, there will be no deformation in the shape and size of the particle, right? So that is why nature is taken as elastic. So this is also true. Next one, collision between macroscopic bodies is generally inelastic. Yes, if body is macroscopic, right, then there will be some contact, and because of that there will be some permanent deformation, and that type of collision is inelastic, right? So statement A, B and C all are true, which is option 3. Question number 15. When a body is projected vertically up at a point P in its path, the ratio of potential to kinetic energy is 3:4. So U is to K is given as 3:4. So its potential energy can be taken as 3x and kinetic energy can be taken as 4x. If the same body were to projected with 2 times the initial velocity, the ratio of potential to kinetic energy at the same point is. So let's assume that initial velocity of the particle is u. So its kinetic energy is half mu square, and this is the reference level. So potential energy can be taken as 0. So this is the total mechanical energy of the system, which is 7x. Right? You can conserve the mechanical energy since no conservative force is there. So basically, half mu square is equals to 7x. Now, you are increasing the velocity of the particle by 2. So, now initial velocity is 2u. So, total mechanical energy will be half m u square, that is 2u ka whole square, which is 4 times half mu square, and that is equals to 4 times 7x, which is 28x. Right? Now, potential energy is given as mgh, right? So, if the location of the point P is same, then the value of h will not change. So, potential energy will remain same in the second case also. So, in the second case, potential energy U1 is 3x and kinetic energy K1 will be total mechanical energy minus potential energy at that point, that is equals to 25x. So, new ratio U1 upon K1 will be 3x upon 25x, which is equals to 3:5, which is option 1. Question number 16. A block sliding along a horizontal frictionless surface with a velocity 2 meter per second comes to the bottom of a frictionless inclined plane making an angle of 30 degree with the horizontal and comes to stop after ascending the inclined plane as indicated. Take the value of g as 10 meter per second square. What is the value of h? So basically at this point the velocity of the block is 2 meter per second and it comes to rest over here after covering a vertical distance of h, right? So in this case again the surface is frictionless. There's no non-conservative forces acting on the system, so you can conserve the mechanical energy. Initial mechanical energy over here is equals to final mechanical energy over here, right? So initial mechanical energy, you can take this one as a reference line. So potential can be considered at 0. Kinetic is half m v square and this is equals to mechanical energy over here. So potential will be mgh plus it stops here. That means its velocity is 0. So its kinetic is 0. Conserve the mechanical energy. Half mu square is equals to mgh. M से m cancel. U square is 2 into 2 divided by 2 is equals to gh. So gh is equals to 2 and h will be 2 by g, which is 0.2 meter. Option 3. Question number 17. A ball at rest is dropped freely from a height of 20 meter. It loses 30% of its kinetic energy on striking the ground and bounces back. The height to which it bounces back is. So, before striking the ground, no non-conservative forces acting on the system. So, potential energy over here will be equal to kinetic energy at this place, which is equals to mgh, right? Because of the conservation of mechanical energy. Now, after striking the ground, it loses 30% of its energy. That means 30% of 70% of energy is left, right? And it bounces back to a certain height, let's say h dash. So, at this point, only potential energy will be there, and that is mg h dash. This is the total pure kinetic energy, and this is pure potential energy. Right, now conserve the mechanical energy. So this is 70 by 100 mgh is equals to mgh dash, mg cancel. So h dash will be 70 by 100 into h. Initial height is 20, so it will be 14 meter. So it bounces back up to 14 meter. Correct answer is option 1. Question number 18. The gravitational force between two bodies is F. If the mass of each body is doubled, okay, so initial masses can be taken as m1, m2 and force can be taken as g m1, m2 upon r square. And the distance between them is halved. That means now the distance becomes r by 2. Then the force between them will be, okay. So F dash is g 2m1 into 2m2 divided by r by 2 whole square. So it is 4 times g m1 m2 divided by r square by 4, which is equals to 16 times g m1 m2 divided by r square. But g m1 m2 divided by r square is the previous force, so F dash becomes 16 times F, which is option 3. Question number 19. A soap bubble formed at the end of a tube is blown very slowly. The graph between excess pressure inside the bubble with time is. So, excess pressure can be written as 4T upon R, and excess pressure is inversely proportional to radius. Okay. So, if radius, if you are blowing this slope bubble very slowly, right, then if radius increases, excess pressure decreases, right, because excess pressure is inversely proportional to r. Fine. So using this relationship, you can see that the relation will be a rectangular hyperbola, which is option 2. Question number 20. A body of mass 2 kg is placed on a horizontal surface having coefficient of kinetic friction 0.4 and coefficient of static friction 0.5. If the force applied on the body is 20 Newton, the acceleration of the body is. So let's find limiting friction first. That is mu s into mg, that is 2 into 10, which is equals to 10 Newton. So applied force is more than limiting friction, so body will experience kinetic friction, right? So kinetic friction Fk will be mu k mg, which is 0.4 into 2 into 10, and that is equals to 8 Newton, right? So in this case, the body will experience 20 Newton in forward direction and 8 Newton in backward direction. So net force will be 12 Newton divided by mass of the body will give you acceleration, which is 6 meter per second square, and that is option 2. Next is question number 28. Which one of the following statements is incorrect? Coefficient of sliding friction has dimension of length. Coefficient of sliding friction is dimensionless. So this one is incorrect. Rolling friction is smaller than the sliding friction. True. Frictional force opposes relative motion. True. Limiting value of static friction is directly proportional to normal reaction. True. So incorrect statement is option 1. Question number 22. Two spheres of mass m and m are situated in air and the gravitational force between them is capital F. The space around the mass is now filled with a liquid of specific gravity phi. The gravitational force will be now. So gravitational force is independent of the medium between the particles, right? So if it is initially F, then finally it will be F only. So correct answer is option 2. Question number 23. The density of a newly discovered planet is twice that of Earth. So let's say this is Earth and this is our newly discovered planet P. So density of the Earth is if rho, then density of the planet is 2 rho. The acceleration due to gravity at the surface of the planet is equal to at the surface of the Earth. So acceleration due to gravity on the surface of Earth and planet is equal. If the radius of the Earth is r, then the radius of the planet would be, let's say it is r dash, right? So acceleration due to gravity in terms of density is 4 by 3 pi rho g r. This value is same for Earth and planet. So let's equate this value. For Earth, it is 4 by 3 pi rho g r, and this is equals to 4 by 3 pi 2 rho into capital G. This is capital G into r dash, right? So 4 by 3 pi, 4 by 3 pi cancel, capital G cancel, rho cancel. So basically we have r is equals to 2r dash. So r dash will be r by 2, which is option 4. Question number 24. If mass and radius of a planet are half that of the Earth. So Earth, and let's say this is planet P. Mass of the Earth is m, then mass of the planet is m by 2. Radius of the Earth is r, then radius of the planet is r by 2. Acceleration due to gravity at its surface would be. So acceleration due to gravity on the surface of the Earth is 9.8 meter per second square. G is given as gm upon r square, which is equals to 9.8 meter per second square for Earth, right? So for planet, it will be g into m by 2 divided by r by 2 whole square. This is equal to gm by 2 divided by r square by 4, which is 2 times gm upon r square. Gm upon r square is 9.8. So in this case, for planet, it is 2 into 9.8, which is 19.6 meter per second square, and that is option 3. Question number 25. A point mass m is placed inside a spherical shell of radius r. So this is spherical shell of radius r, and one point mass is placed at a distance r by 2 inside the shell. The gravitational force exerted by the shell on the point mass is. So gravitational force is m into gravitational field intensity. Inside the spherical shell, gravitational field intensity is 0. So if gravitational field intensity due to the spherical shell inside is 0, then force on this particle will be 0. So correct answer is option 3. Question number 26. A heavy uniform chain lies on horizontal tabletop. The coefficient of friction between the chain and the table surface is 0.25. So let's say this is chain and some part of it is hanging like this, right? Coefficient of friction is given as 0.25, which is 1 by 4. We need to find the maximum percentage of the length of the chain that can hang over one edge of the table is. So let's say total length is capital L and total mass is capital M. So mass per unit length is m upon L. Let's assume that L part of this length is hanging. So mass of this part will be m upon L into L. And remaining part L minus small l is on the table. So its mass will be m upon L into L minus L. Right? Now this gravitational force m upon L into G is responsible for pulling this chain in the downward direction, right? So if this gravitational force is balanced by the friction over this part, then this chain will be at equilibrium, right? So friction will be mu mg, so it is mu, which is 1 by 4 into m by L into L minus L into G is equals to m by L into G, right? So m by L, G cancel each other. So we have L minus L is equals to 4L. So L is equals to 5L. So L will be L by 5, which is 20% of the total length. So maximum percentage of the length that can be hung over one end of the table is 20%, which is option 1. Question number 27. Masses 2 kg and 8 kg are 18 centimeter apart. The point where the gravitational field due to them is 0 is, let's say that point is over here at a distance x, right? So gravitational field at this point should be 0. That means gravitational field intensity due to 2 kg should cancel gravitational field intensity at 8 due to 8 kg. So this remaining distance will be 18 minus x. Gravitational field intensity due to 2 kg is g into 2 upon x square, and it should cancel g into 8 divided by 18 minus x whole square. So basically this is 18 minus x whole square is equals to 4x square. Take the square root. So 18 minus x is equals to 2x and x will be 6 centimeter. So gravitational field intensity is 0 at a distance of 6 centimeter from 2 kilogram mass, which is option 2. Question number 28. Two particles of masses 4 kilogram and 8 kilogram are kept at x is equals to minus 2 meter and x is equals to 4 meter respectively. So this is 4 kilogram, this is 8 kilogram, and this is origin 0. Then the gravitational field intensity at the origin is. So at the origin, gravitational field intensity will be due to two masses, 4 and 8, right? So because of this mass, gravitational field intensity will be in this direction. It is always towards the mass, right? Let's say it is E1, and because of this mass 8 kilogram, it is in this direction. This is E2. So E1 is G M divided by r square, which is 2 square, which is equals to G. E2 is G M divided by r square, which is 4 square. So it is G by 2. So we have intensity of G in this direction and intensity of G by 2 in this direction. So net intensity will be G by 2. G minus G by 2, G by 2 in this direction, which is option 3. Question number 29. A rubber ball drops from height h. After rebounding twice from the ground, it rises to h by 2. The coefficient of restitution is. So basically h dash is e power 2n into h. So h dash is h by 2 is equals to e power 2 into number of, it rebounds twice. That means n is equals to 2 into h. So e power 4 is 1 by 2. So e will be 1 by 2 to the power 1 by 4, which is option 3. Question number 30. A horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. That means normal reaction R is 10 Newton. Its mgw will be in the downward direction and friction will be in upward direction. It is in equilibrium. That means friction is balanced by W, right? Coefficient of friction is 0.2, the weight of the block is. So weight is friction, which is mu into R, which is 0.2 into 10, and that is equals to 2 Newton. So W is equals to 2 Newton, which is option 1. Question number 31. A uniform steel rod of cross-section area A and length L is suspended so that it hangs vertically. So we have a rod of cross-section area A and length L. It's suspended vertically. The stress at the middle point of the rod is. So this is the point where we want to calculate the stress. So at this point, the force experienced will be mg by 2. Mass is volume into density. So volume is area into length into G divided by 2. So this is rho ALG divided by 2, that is your force. Force per unit area, force upon area is known as stress. So it is rho ALG by 2 divided by area. So it will be rho LG by 2, which is option 1. Question number 32. A steel wire is stretched by force F and longitudinal strain produced in the wire is E. If the radius of the wire is doubled, if radius is doubled, then the area is 4 times because area is pi r square. If radius is doubled, then A dash will become 4A. And same stretching force is applied, then the longitudinal strain will be. So, stress is directly proportional to strain. Okay. Or you can say that that stress is gamma times strain. Stress upon strain is gamma, Young's modulus, right? So if you are increasing the radius by 2 times, then area will increase by 4, right? Then stress will become F upon A, and in the next case it will be F upon 4A. So stress will become 1 by 4 times. Since strain is directly proportional to stress, then if stress is 1 by 4 times now, then the strain is also 1 by 4 times, which is option 2. Question number 33. A body is subjected to strain a number of times, does not obey Hooke's law due to elastic fatigue, right? So option 3 is correct. Question number 34. A cube of side 0.30 meter is subjected to a shearing force F. 6 into 10 power 6 Newton, assuming that the shear modulus of the material is 4.2 into 10 power 8 Newton per meter square, the angle through which the cube shear in radians is approximately. So eta is F upon A theta. So theta will be F upon A eta. F is 4.2 into 10 power 8. A is cube. That means it is A square. So it is zero point 0.3 whole square into eta is, sorry, this is 6 into 10 power 6. 6 into, let me correct this one. F is 6 into 10 power 6. This is 4.2 into 10 power 8. So if you solve this one, you'll get approximate value of theta as 0.16 radians, which is option 2. Question number 35. A cube of 10 Newton rests on a rough inclined plane of inclination. Theta is equals to sine inverse 3 by 5. So if sine theta is 3 by 5, then cos theta will be 4 by 5. The coefficient of friction is 0.6. The minimum force necessary to start the cube moving up the plane is. So this is theta. This is cube of mass m. So this will be mg. This will be normal, right? And if you take the components, this component will be mg cos theta. This component will be mg sin theta, right? And if you are trying to move this cube in upward direction, friction will be in the downward direction. So minimum required force should counter friction plus mg sin theta. So F minimum should be friction plus mg sin theta. Friction is mu into n plus mg sin theta. N is in this case mg cos theta. So it is mu mg, which is 10 into cos theta 4 by 5 plus mg, which is 10 into sin theta is 3 by 5. So if you add this one, you'll get your answer as 10.8 Newton, which is option 2. Question number 36. Terminal velocity of a ball of density rho and radius r and liquid density sigma by 2 and viscosity eta is V. So V is directly proportional to r square into rho minus sigma minus rho divided by eta. So in this case, V is directly proportional to r square minus sigma by 2 divided by eta. So you can write it as V is directly proportional to r square sigma upon 2 eta, right? Similarly, for the second case, what will be the terminal velocity of ball of radius 2r made of the same material but liquid density sigma by 3 and viscosity 2 eta, right? So in this case, it will be V dash is directly proportional to 2r square into sigma minus sigma by 3 divided by 2 eta. So it is V is directly proportional to V dash is directly proportional to 4r square upon 2 eta into sigma 2 sigma by 3. So it is 4 times 4 by 3 times r square into sigma upon eta, right? So if you compare equation 1 and equation 2, you will get your new value of velocity as 8v by 3, which is option 4. Question number 37. In a YouTube experiment, a column AB of water is balanced by a column CD of paraffin. The relative density of the paraffin is. So let's say density of the water is rho W and density of the rho W and density of the paraffin is rho P. So over here, H1 height is balanced by H2 height of the water, right? So pressure at point B is equal to pressure at point D, right? This is B, this is D. Okay. So pressure at point B is P naught plus rho W into G into H2, and this is equals to pressure at the point D, which is P naught plus rho P into G into H1. So this will cancel this one. So we have rho W G H2 is equals to rho P G H1. G se G cancel. So we have rho P upon rho W, that is H2 divided by H1, and density of a substance divided by density of water is your relative density. which is H2 by H1, which is option 2. Question number 38. Rate of volume flow of a viscous liquid through a capillary tube of radius r and length L is Q under same pressure difference between the ends of another capillary tube of radius 2r and length 2l. What will be the rate of volume flow of the same liquid through it? So basically Q is given as pi upon 8 r power 4 into delta P upon eta L, right? So this is for the first case. For the second case, Q dash is pi upon 8. This is 2 r power 4 delta P upon eta into 2L. So it will be 8 times pi upon 8 r power 4 delta P upon eta L. Right, so it becomes 8 times the previous one. So Q dash is 8Q, which is option 2. Question number 39. A river of salty water is flowing with a velocity of 2 meter per second. Density of the water is 1.2 gram per cc. Then the kinetic energy of each of cubic meter of water is. So kinetic energy per unit volume is given as half rho v square, which is half rho is 1.2 into 10 power 3 into v square is 2 into 2, which is 2.4 into 10 power 3 joules. And this is equal to 2.4 kilojoules, which is option 4. Question number 40. A pump of 200 watt power is lifting 2 kilogram water per second. So basically work divided by time is 200 divided by 1. Right? Okay. 200 into 1. Not divided by 1. It is 200 into 1. Work done by this pump is 200 into 1, that is power into time. Okay, power into time, that is equals to 200 into 1, and this work is converting into kinetic energy as well as potential energy of the water. So kinetic energy is half m v square plus potential energy is m g h, right? So if you solve this one, you'll get v square as 4 and v is equals to 2 meter per second, which is option 1. Question number 41. Two identical spheres of gold are in contact with each other. The gravitational force of attraction between them is. So we have two identical spheres, something like this, and these two are in contact with each other. Right, so mass of this one is m, then mass of this one is also m. Mass is density into volume. So density into 4 by 3 pi r cubed is the mass. Gravitational force between these two spheres will be g m into m divided by 2r whole square. Separation between the centers is equals to 2r. So it will be g into 4 by 3 pi rho r cube whole square divided by 4r square. So you can see that using this expression that force is directly proportional to r power 4. So correct answer is option 3. Question number 42. A body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down the center of the earth? So W dash will be mg dash, which is equals to mg dash at a depth d is g into 1 minus d upon r. So mg is 200 into 1 minus d is r by 2. So r by 2 divided by r is 1 by 2. So 1 minus 1 by 2 is 1 by 2. So it is 200 into 1 by 2, which is 100 Newton. So correct answer is option 2. Question number 43. A steel sphere of mass 3 kg moving with a velocity of 6 meter per second collides head on with a stationary sphere of mass 6 kg. If the coefficient of the restitution is 0.5, the loss in kinetic energy in the process is. So loss in energy is given as half m1 m2 upon m1 plus m2 into 1 minus e square into u1 minus u2 whole square. So half m1 is 3 into m2 is 6 divided by m1 plus m2, that is 3 plus 6 9 into 1 minus 1 by 2 whole square into u1, which is 6 minus 0 square, right? So it is, this will be 18 divided by 18, 1 into 1 minus 1 by 4 is 3 by 4 into 6 square is 36. So it is 27 joules. So correct answer is option 4. Next is the gravitational potential energy of a body at a distance r from the center of the earth is u. So minus g m1 m2 upon r is u. So basically the magnitude of g m1 m2 is equals to ur. Its weight at a distance 2r from the center of the earth is. So weight will be m2 times g m1 upon 2r whole square, where m1 is the mass of the earth. Then in this case it will become g m1 m2 divided by 4r square. G m1 m2 is ur, so it is ur divided by 4r square. So this is u upon 4r, which is option 2. Next is question number 45. The diagram shows the stress strain graph of two different materials A and B. Two rods A and B made of material A and B respectively have same length and cross section area. The rods are subjected to same tensile force. Total elastic potential energy stored in A is U2 and that stored in B is, this is U1, stored in A is U1 and stored in B is U2. Then which of the following relation is correct? So total elastic potential energy is sigma square upon 2 gamma into volume, right? If area is same, length is same, force is same, then sigma is same. So U is inversely proportional to gamma, Young's modulus. Stress versus strain curve ka slope will give you what? Gamma. So slope of A is more as compared to slope of B. That means gamma of A is greater than gamma B. So if gamma is more for A, then its potential energy stored will be less. So U1 is less than U2, which is option 2. Question number 46. What should be the angular velocity of rotation of Earth about its own axis so that the weight of the body at the equator reduces to 3/5 of its present value? So present value is mg. Okay. G at equator is g dash is g minus omega square r. Okay. So 3/5 of mg will be m times g dash, which is g minus omega square r. So it will be 3/5 mg is equals to mg minus m omega square r, right? So m omega square r will be 2/5 mg. So basically omega square will be 2g divided by 5r. So omega will be under root of 2g divided by 5r, which is option 3. Question number 47. A body, a mass m, moves with velocity v and collides inelastically with another identical mass m at rest. After collision, the first mass moves with velocity v by root 3 in the direction perpendicular to the initial direction. Find the speed of the second mass after the collision. So let's say second mass is moving with velocity v dash in this direction with some angle theta with the horizontal. So this component will be v dash cos theta and this component will be v dash sin theta. So initial momentum along x-axis should be equal to final momentum along x-axis and initial momentum along y-axis should be equal to final momentum along y-axis, right? So initial momentum along x-axis is mv, which is equals to mv dash cos theta. So v dash cos theta is v. Similarly, final momentum along y-axis is m v by root 3 minus m v dash sin theta and it should be equal to initial momentum along y-axis, which is 0. So यहाँ से v dash sin theta will be v by root 3. So v dash is the vector summation of these two components, which is under root of v square plus v upon root 3 square. So it is 2v upon root 3, which is equal to option 1. Question number 48. A body of mass m having momentum p is moving on a rough horizontal surface if it is stopped in a distance x. So momentum is mass into velocity, which is p. So initial velocity is p upon m. It is stopped at a distance x. The coefficient of friction between the body and the surface is given by. So basically, you can apply v square is equals to u square plus 2as. V square is 0, u square is p upon m whole square plus 2, a will be minus mu g into s is x. So mu will be p square upon 2 g x into m square, which is option 3. Question number 49. The coefficient of static friction μs between the block and the surface is zero point 0.2. Block is 2 kilogram. What would be the maximum mass m of the block B so that the two blocks do not move, right? And take the value of G as 10 meter per second square. So basically this mg is balanced by tension over here. So T is equals to mg, and at the same time this tension is balanced by friction provided by the surface. So T is equals to friction. So basically friction should be balanced by mg. Friction over here is mu into m into g, and this should be equal to mg. So g will cancel this g, so m is 0.4 kilogram, which is option 4. Question number 50. The upper half of an inclined plane of inclination theta is perfectly smooth and the lower half is rough. So if you take upper half, this is smooth and lower half is rough. So let's say this length is s, this length is also s, total length is 2s. A block starting from rest at the top of the plane will again come to rest at the bottom. So initial kinetic energy is 0, final kinetic energy is also 0. So change in kinetic energy is 0. If the coefficient of friction between the block and the lower half of the plane is given by, then what should be the coefficient of friction between the block and the plane? So basically this is mg, right? And this component will be mg sine theta, and this will be mg cos theta, and this will be normal, right? So work done by mg sine theta will be mg sine theta into 2s, because it is acting for 2s distance. Work done by normal plus work done by mg cos theta will be 0, because perpendicular to the direction of displacement. Work done by friction will start from this point, and that is equals to minus f into s. Why? Because friction is in backward direction, velocity is in forward direction. Friction will be mu into n, so it is mg cos theta into mu, right? Now this total work done should be equal to change in kinetic energy, which is 0, right? So basically mg sine theta into 2s should be fs, which is mu mg cos theta into s. So mg will cancel this mg, s will cancel this s. So we have mu cos theta is equals to 2 sine theta. So mu is 2 tan theta, which is option 1. I hope this is clear. So thank you so much everyone. Take care.